Welcome, dear students, professors, and attendees from Austria, Germany, Spain, France, Great Britain, Italy, Ireland, Netherlands, Norway, Poland, Portugal, Russia, Sweden, Turkey, South Africa, and the overseas and friends. We are very pleased to have you on board. My name is Joseph Plaza. I am Safety Product Marketing Manager at Omron Europe. I've been working in automation and robotic safety world since 1994, worldwide and mostly in Europe. I've been also safety inspector from Deutsche Akkreditierungsrat since 2002 from Germany. I have been appointed a qualified expert member of standardization committees such as ISO, IC, such as Industrial Robots and Safety Motion. And on behalf of Omron European team, I will be your presenter today. Our today's agenda, you will see a short introduction: who is Omron in automation, which are the legal steps for a safe machinery, machinery safety circuit and safe state hierarchies, example of education projects in Italy, wrap-up summary, and we can attend your questions anytime in the local chat in your local language. In any automation system, and you as automation system designers, automators, do you think that safety circuits are necessary? Please share your opinion on the screen. Safe automation is everywhere. You, as automators, during the design stage should analyze the hazards and evaluate the risk generated in the machine and include your proposal in the design to make the machine safe. So in Europe, the machinery of all kinds of machines should have several circuits such as source of power, control system, and safety. When you drink some beverage from a can, you may imagine how this can has been made. The machine builder should take into consideration the hazardous situation in the entire life cycle of the machine. The machine user should keep and maintain the machine according to the original design. The European Legal and Technical Framework, which is mandatory since 1st of January 1995, forces some different stages in the European machinery. So that means if you are outside of Europe, you doesn't need to fulfill that. But if you are selling using machinery in Europe, you are forced to use that. You can identify that looking on the machine, the CE marking logo. For the machine user, which is the owner, the production, enforces the users with CE market machinery to be used and maintain the machinery only following the instructions of the machine designer. Also forces to keep the machinery in safe conditions during the working lifetime, including regular inspections. You can find further information in the European Directive 2009/104/CE. If you are a machine builder and forces you to to comply with the special procedures within the CE marking, building only machinery which should be safe for the users. You can have further information in the European Directive 2006/42/CE. But which are the duties of the machine builder when designing machinery with CE marking? So first of all, elaborate the technical file for the machine, including the risk analysis. This information is top secret, needs to keep in the machine builder facilities. Secondly, build the machine, taking into consideration the entire working lifetime, approximately 20 years. Third, elaborate operating instructions for user maintenance, cleaning, etc. Fourth, sign the CE Declaration of Conformity. Fifth, attach the CE marking into the machine and also put the CE logo. But in case you are maintaining this machine, so which are the duties of the machine user, the owner, when using CE market machinery? That means this machinery. So the step number 1, which is the 6th on the entire system, is accept or reject the machine use and use according to the operating instructions manual. So you should review that. The step number 7 is purchase, the last payment term. 8th is use and production, fabrication in progress during the entire working life, over 20 years, and also do maintenance and troubleshooting. Maintenance, repair, and cleaning, it's also a stage of the production in progress, and put the machine out of order. But which is the behavior of an automation system? Which is the failure reaction? Any automation system or automated part can have unexpected events, but what is the failure reaction to failure? If we are unlucky, the system fails randomly. If we are lucky, the system fails sporadically. If we are really lucky, system doesn't fail or fails sporadically. So we must anticipate these failures and react in a safety way. So, bearing in mind you have these 4 possibilities, in which status will you be? Number 1, number 2, number 3, number 4. The safety systems are classified in 5 levels. Performance level required A, B, C, and D. Independently of which are the safety function. It could be an emergency stop or protective stop. Which do you think is the most used safety function in machinery? Guard monitoring, guard interlocking, sensor guard monitoring, selector operating mode, enabling device, emergency stop, safety light curtain, safety protections, safe laser scanner, safety mat or edges, and safe monitored speed. According to the German Machine Builder Association, and based on an analysis made on 300 machines, the most used safety functions are emergency stop, 99% of the cases, guard monitoring, 81%, guard interlocking, 73%, operating selecting modes, 58%, safe light curtains, 56%, sense guarding monitoring, 52%, enabling switches, 49%, safety light barriers, 49%, safe speed monitoring, 44%, safe laser scanner, 23%, safety mats and safety edges, 22%. In any industrial automated process, we are mixing humans in different operations and machinery, and that makes some risks. In any process, we need to integrate safe automation and the interaction among these hierarchies. Let's have a look on the example of emergency stop. So if we have someone that is pressing the emergency stop because he's in an emergency situation, the information will trigger the input. We have a kind of logic which will end in power off. So remove the energy on the dangerous movement, and in parallel will inform the protective stop layer and also the regular situation layer. So that means here we have different interaction on the hierarchies for emergency stop situation. Let's have a look on one example. This example is a kind of machine user empty can palletizing machine, which is palletizing cans empty into a pallet. We need to take in consideration all dangerous movements and therefore the hazards that are existing, which are the moving and up and down movements. This machine needs to be observed for any position and any parts on process, like process, maintenance, using the machine, etc. What should happen if, for some reason, somebody sees in the emergency situation and needs to press the emergency stop push button, like this guy? A single human action needs to disconnect, power off the dangerous movements, as you can see in the image. In this slide, you can see a different interaction. Not the emergency, we want to see the protective stop, the safety circuits. In this case, the door, which need to be interacted with the human action, with the key, an operator selector key, and also reduce the safety speed movement. So in this case, the protective stop, which is the second layer, will work as a reduced speed. And together is the second signal that we need for the layers and the hierarchies for the starting or stopping the machine. Let's have a look on the can liquid filling machine. In this can liquid machine, which are working at regular speed, but when operator needs to do some activity, we started the safe slow speed and direction. We can open the door, do the safe maintenance in a safety way, and also in parallel, if emergency is needed, emergency stop circuit will power off the machine. So we can work in safe maintenance mode with all safety warranted. But how the safe circuits should interact with the power control system, etc. in the machinery? We have the power, which can be electrical, software power, pneumatic, hydraulic, any kind. These parts are more linked with the movements and the dangerous parts. We have the control system, which can be electrical, pneumatic, electronical, programmable. And also we have the small intersection, which is safety related parts of the control system, which can be electrical, pneumatic, electronical, programmable. These safety parts can be combined only with the control system, which is marked here with the number 1, or these parts can be interacting control system, power, or safety. Or number 3 is marking only safety control part with power. And the number 4 marks only the section which is safety. So this is the hierarchy concepts and interaction of the circuits. And we need to design all the machines taking consideration that the safety related parts of the control system can have several positions, like safe isolated, safety integrated, a standard and safety, and safety fully integrated also in the cloud, exchanging information in the cloud for Industry 4.0. Now, let's have a look on the required information for machinery, because many of this information or many of these components are really on fashion, but they are not legally demanded. So let's start for the cloud. So the cloud has using a lot of components, and their duty is processing and sharing information and statistics. There is no legal requirement for that. It's just a market demand. Let's continue with the tower light. The tower light has the purpose or the duty of giving information about the status of the machine for multiple users. So that means this part is yes, is mandatory for the legal requirements. The way that you are using the tower light, it's on the design, but the colors and the information is on the standards. Let's continue with the touch panels or the human-machine interfaces. The purpose of that is to give information to a single user information, and they are not mandatory. It's a trend or a market demand, very useful, very powerful systems, but they are not legal required. Let's continue now with the push buttons and the lamp indications. Again, these ones are single user informations, the operator who has the push buttons in front, and that are also mandatory. So if you want to use push buttons separated of light bulbs, or you want to use integrated, it's on your own design, but they are mandatory. And last but not least, the operating instructions and manuals and indications, educations. So that is also single user information, but it's mandatory according to the machinery directive and equipment standards. Let's start in a deep look on the typical safety module internal functionality. Here you have some examples and how they are working internally. Let's start first and understanding what is the typical safety module internal functionality. Here we have a safety module, how it looks like internally and how it's designed. So therefore we need to take in consideration for the application and installation. First of all, we are looking for the safety inputs, channel 1, channel 2, T11, T12, T21st to 22nd. Secondary, the safety outputs. As you can see, we have a 13, 14, 23, 24, which is instantaneous contacts, and 37, 47, 38, 48 for the delay of safety outputs. And we have a logic and the power circuits represented here. All safety circuits need to work with positive logic. And which is this approach? So when we are working with positive logic, that means the protections are closed or the emergency stop is not pressed, all signals must be on when safe situation is protecting. Be aware of the individual functionality on each function. When you open a guard or press the emergency stop or actuator or any failure or any error occurs, the signal must be or will be disconnected. The safety functions are affecting all dangerous movements. Therefore, we must take on all consequences, such as protective store, monitoring, emergency stop, disconnect. The power source supply. Electrical power. So the power supply regularly is 24 volts with a plus minus of tolerance range. The voltage supply is permanently monitored by safety module, and if it's out of range, we disconnect. Using SLB and PLB, this supply is satisfying the requirements to prevent electric shocks. The safety inputs. We can have a single channel or dual channel, depending on which kind of inputs we are using, like electromechanical inputs from emergency stop doors, etc. We are doing electromechanical contacts. Or we can use like safety light curtains, we can have a OSSD inputs, which are output switching signal devices. Now the reset function. Each safety module has a kind of logic, and according to the wiring or the selection you will do, the module will react differently. So for automatic reset, that means no human action is required. So we will wire the contacts in some way. Differently, if we need a manual reset, which we cannot exchange, is wiring. So the designer of the machine needs to implement that, and that will keep forever. So the operator is demand to observe which is the situation, think on that, and act. When they are acting, they are pressing the push button, and this is a normally open push button that will give us a kind of signal status, off, on, off, and that will give us a kind of code that needs to be understood from the logic in order to go ahead. But as the primary safety function, it could be a door, it could be emergency stop, a light curtain, etc., needs to activate or switch off some outputs. So before this signal is understood regularly, we have in a serial connection what we call EDM, which means external device monitoring. So depending on the output components that we are switching on and off, and after the primary safety function is activated, human observe, think, and act correctly. Everything is under control. Contactors or elements has been switched off or powered off, so they close the contacts. So we'll be in this status. Then the press and release the reset switch button will activate the signal on, off, and the module will start operating. Now it's time to interact with the safety module with the outputs. So we have two kinds of outputs: auxiliary outputs, non-safe, and safety outputs. Let's start with the auxiliary outputs, which the purpose is to connect with the standard PLC and light tower to inform operators or to inform the process in which status we are. These outputs are not suitable for safety functionality. And the safety outputs that, depending on what we are connecting, contactors, valves, inverters, or the output circuit, we will use instantaneous safety outputs or delay off or delay on safety outputs. This conceptual drawing is showing to us the typical safety module application by different colors. So cables here are just indicating which are the part for a standard indication: blue, red for the safety circuit, black for the power control system. The safety circuit, which is painted in red, are directly linked with the performance level required. So we have 5 levels of performance level, from low to high. And depending on the danger that our machine has, we need to identify and reply some responses inside of the risk assessment. And we will have the result of performance level A for a low level, B, C for medium, D or E for high. Now we will have an example of a low risk machine, which is performance level A or B. Let's have a look on the power part. We have 2 motors for this machine, which is affected by the push buttons and also the door switches in the lowest performance level we can find. So we identify the safety components, in this case emergency stop, start stop, the door switches, etc. And here we have the electrical wires. In this case, we are using a standard PLC, an emergency stop push button number 1, number 2, a start, a stop push buttons, the guards, and also the resets. In this case, electrically, the emergency stop push buttons are serial connector with the standard and a stop push button, which are inputs from the standard PLC. And also in parallel, we are cutting the source of powers of the common part of the output. So that means in the case of emergency stop, we will inform the standard PLC with the input, and also we cut the power so that the outputs will be ensured that will be switched off. Here we have an example of a low medium risk machine with a performance level C. The power part and the rest of the examples, like with red, colored, safety related parts of the control system, green, connections with safety module and a standard PLC, and blue, connection standard PLC with control system. The emergency stop push buttons are serial connected to the safety module. Each guard is connected individually with the safety module and has their own individual reset push button functionality, same as the emergency stop individual function reset functionality. And the output of the reset module is connected with the start and stop of the machine and also informing the situation on the standard PLC. In parallel, we are cutting the common of the power source of the outputs of the standard PLC, and we are powering the door monitoring safety PLC guard. With that, we ensure that although we are opening the door or we are pressing the emergency stop, we are disconnecting each of the contactors, which will be disconnecting each of the dangerous motor. Now, our last example, a robot cell which is producing big pieces for automotive. In this case, the performance level is between D and E, which is performance level require high level. We will focus on the safety function of emergency stop, safety function of light curtain, and safety function door monitoring and guard interlocking. Let's continue on the details with the electrical drawings. First, we need to identify which are the components, and therefore, as emergency stop, safety relay module, interlock gate, safety module, light curtain module, standard PLC. So, have a look on the wiring. Here we have the circuit for the emergency stop. Emergency stop, as this is a highly risk machine performance level E, we need to wire the module with 2 channels in order to detect errors between them. Also, we will use the 2 channels from the interlock switch wired to the safety module, and also the 2 channels from the light curtains. So all these modules will share information with the standard output with the standard PLC, and also they have the individual reset functionality localized. So the emergency stop is again switching off the power for the outputs of the standard PLC, and at the same time giving the power to the safety module for the protective stops. With that, we ensure that the contactors and all the motion which is within this area is affected from the emergency stop or the door or the light curtain. Remember, every time you use a can or tin, that any industrial process needs to have a CE marking process on, which should include all the parts and subparts. All machines need to have a risk assessment and take the results in the design process for their entire lifetime. Users of the machines need to follow the instructions of the machine and fulfill the periodic safety inspections during all their working lifetime. Remember the duties for the machine designers and users. Of course, if we are inside of Europe, the CE marking means that the machine owner or user needs to fulfill the instructions of the machine builder, and machine builder needs to do the CE marking process accordingly. Also, take in consideration the information from risk assessment and use the risk assessment information into the performance level required from low to high. And that means we need to use well-tried components for all functionalities in safety. The function test will be on the startup or permanently 24 hours, 7 days a week, or using 1 or 2 channels as a redundancy. Omron is engaged with the educational communities around the world. As an example, we want to show how our Italian colleagues are doing.
Omron Educational Project. What's that? The Omron Educational Project started in 2003 when we began to support some technical schools in their activities. The project involves today universities, ITS, as well as technical high schools throughout Italy. It wants to give students and teachers the opportunity to work with the software and hardware tools of the industrial world. Teacher trainings take place through specific face-to-face and online courses on the main automation topics. The Smart Project Trophy is a contest that tests students' skills and technical knowledge in the implementation and presentation of an automation project. Winners are awarded with scholarships. Automation product bundles are provided on favorable terms to create state-of-the-art school laboratories. With ITS and universities throughout Italy, we carry out training sessions for students as well as we take part in seminars, events and conferences. Omron Educational Project, that's it!